So we learned a whole bunch of definitions yesterday. We talked about subsets. We said if something is a subset, that everything in the first letter is is all in the second letter. So A is a subset of B. Everything in A is in B. We talked about empty sets, which didn't make a lot of sense. They will today. We talked about prime numbers. What's the first prime number? 2, not 1. 1 is not prime. 2 is the first prime and only even. First prime, only even. Okay? So the first prime number, only even number, is 2, then 3, 5, 7, 11, 13, 17, 19, etc. It's when it's 1 and itself is only factor. Composites have to have at least 3, and therefore 1 isn't a composite nor a prime, it's just its own little entity. Okay? So today we're going to talk about intersection and union of sets, and it has like the little symbols over here. Intersection is this symbol, union is the U. But what the heck do they mean? So that's what we're going to talk about today. So we'll use the example on the previous page to introduce further terminology used in set theory. So we have set E was 0, 2, 4, 6, 8. Set L was 0, 1, 2, 3, 4, 5, 6. And set O was 1, 3, 5, right? That was what we did yesterday. We had those 3 sets. So we're going to talk about the intersection of sets. So the intersection is this symbol. Okay? It's just an upside down U. Now, one of them is and one of them means or. Okay? So how do I know that this one means and? Because I can write the word and out of it. So that's why I know it's and. And then union is the U, and if I try and write the word and out of it, it looks stupid. Therefore, it is or. That's how I narrow it down. So the downwards U for intersection can write the word and with it, and this one I can't. So this is and this is or. And we'll discuss what that means in a second. So if you forget that intersection is that symbol, your formula sheet does tell you that, right? So you can look at your formula sheet. It shows you that it is that downwards U. The intersection of set A and B is a set called A and B, and it is denoted by A with upside down B, so that means and. It is a set of all elements that are members of both sets. So if you're in A and in B, I would write it. So it has to be in both, correct? So for example, if I took the people in this class and I said raise your hand if you're in social, and then I said raise your hand if you're in math, I would only take the people that are in social and math, and I would write them down, because that's intersection. Intersection has to be in both. Okay? So we want to write the intersection of sets E and L. So how do I write that? I go E intersection L. And now I'm going to write only the things that are in E and L. So in E and in L, I have 0, 2, 4, and 6. Correct? Those are the numbers that are in E and in L. So they're in the intersection. I don't list anything that's not in both. It has to be in both, and then I list it. Okay? That's the intersection. Then we have the union of sets. So the union of set A and set B is a set called A or B, and it is denoted by A union B, that little symbol. It is the set of elements that are members of either set A or set B or both. So if I told you to raise your hand if you're in social, and I told you to raise your hand if you're in math, then I would write anyone who's in social or in math, and that would be union. So you would get way more people, because if you were in social or you were in math, or you were in social and math, I would write all of you. Okay? So for example, I want you to raise your hand if you like blue. Okay? Now keep it up. Now raise your hand if you like French fries. Okay? I would list all of you now if it was union. Correct? Every single one of you. Because if you liked blue or French fries, I would list you. So I'd list all of you. So that's a lot more. Okay? Now the people who liked blue and French fries only, put your hands up. Blue and French fries. Is that way less people? Yes, because you have to like blue and French fries to be listed. So intersection often has less people because you have to be in both sets to be written down, correct? But union, as long as you're in one or the other, as long as you like blue or French fries, you were listed. If you like both, cool, you're still listed. You're just not listed twice. Okay, so union often has more, because it's if you're in this one or in this one, I list you. And you have to be in both, or you cannot be listed. Okay, so now if I look at this one, they want the union. So E and L, E intersection L, I only listed the ones that are in both. E union L, I list the ones that are in either or. So there's going to be a lot more, correct? Because if you're in E or you're in L, I list you. If you're in both, cool, still list you, but I just list you once. So 0 is in E and L, 1 is in L, 2 is in both, 3 is in L, 4 is in E and both, 5 is in L, 6 is in E, 8 is in E, 6 is in L too. So if it appears in E or it appears in L, I write it. So or often results in more, or and more, because if you're in either or, I write it. If you're in both, still write it. Okay? So and means I have to be in this and this. You have to raise your hand if you liked blue and French fries. If you just like blue or you just like French fries, you weren't raising your hand then. So it's less people, correct? But if you like blue or French fries, you could like one or the other and still raise your hand up. If you like both, still raise your hand up. So it would be more. Okay, disjoint sets. This is one that people often forget about. Disjoint sets are two sets. Two sets are said to be disjoint if they have no elements in common. So if you do the intersection of the two sets, it results in the empty set. So here I have the set 2, 3, 4. The first set contains the numbers 2, 3, 4. The second set contains the numbers 5, 6, and 7. What do they have in common? Nothing. So if I went and I said the intersection of these two sets, it would be the empty set because there would be nothing in it, because there is nothing in both. So let's use it with actual sets. So which two sets, E, L, or O, are disjointed? So which of those three sets have nothing in common? E and O. E is even, O is odd, so they're opposites, right? So I would, to show that, how do I show it's disjoint? I go E, intersection, that is, I said E and wrote an O. Anyone worried right now? Anyone? I am. I'm concerned. What is going on? I looked at the O, I don't even know what just happened there. It's recorded for future reference when I have to explain why I'm not teaching anymore, because I wrote an E, O instead of E. Okay, E and O. Maybe because I was saying the word O at the time when I was trying to, I don't know, I got nothing. It did involve an O at some point. Okay, could I have went O and E? Would it matter? No, it wouldn't have. I just was saying it the other way, so I have to say it that way. But if I go E and O, or I go O and E, intersection E, they both will result in the empty set. So you still write the squiggly brackets, but to represent empty set, you could leave it empty, but they more than often will go 0 with a slash, because if you look at your formula sheet, it shows empty set. 0 with a slash, right? So it's on there. And they're empty because they have nothing in common. Would E or O, though, guys, if I did this, E union O, would that result in an empty set? Anything in E or an O would be listed, correct? So it would actually be 0, 1, 2, 3, 4, 5, 6, 7, 8. It would actually be the universal set, because it would be everything, right? E or O. Okay, example 3 written on the bottom of the page, but we're going to the next page to do it. I want you guys to try this. 1 and 2 and 3. Remember, the complement is everything in the universal set, but not in A for this one. The universal set is the natural numbers less than 20. So if we have the natural numbers less than 20, what are we starting at? Natural numbers. What do we naturally start counting as a child? 1. And then it says less than 20, so we're going to 19, right? 1 to 19, all the numbers in between. Okay. We do need that universal set when we get down to this A complement, right? Because that's how we get the complement, is everything that's not in A but in that universal set. So I'm going to list the complement of A down here as well. So the complement of A is everything from 1 to 19, but not 3, 6, 9, 12, 15, or 18, correct? So it would be 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. Now, some people choose to not write them out. Why to not write them out is sheer just, I'm lazy and I don't want to write it out. That's the only reason why you wouldn't write it out, correct? The people who don't write it out will often get it wrong because you'll miss a number here or there. Because that's a lot of numbers to look at, trying to make your brain work around, like which one is it and I don't remember. So it's better to just write it out. So if you're like, oh, I don't want to write it out because I'm feeling lazy, be like, no, I want the marks. So I write it out and I stop myself from being lazy. Okay? So here we need A intersection B. If I don't remember if that's an and or an or, remember I can take the shape and try and write the word and. And if it does write the word and, it's and. Correct? So I want what's in A and in B. So it has to be in both. A and B. So what's in A and B? 15. Very close to being an empty set, correct? But there's still, it's not. It's the number 15. Then we have this one. If I try and draw and with it, it looks stupid. So I know it's not and, it's or. That's my hardcore mathematics into deciding whether it's and or. That's it. It's stupid, but it works. So just try it out. Okay? Or means more. So if it's in this or it's in this, I write it. Okay? So if it's in A or it's in B, I write it. And remember, this can work into the word more, right? Or means more. So it's going to be more than the and. So A or B. So I have 3, 5 is in one of them, 6, 9, 10, 12, 15's in both. Do I need to write it twice? No. Do I need to write it once? Yes. So if it's in one or the other, I write it. Okay? Then we want this one. Once again, this one is an and because of the shape. So I need to find out what's in here and in here. What's in both of them, correct? It's a lot harder to be like, okay, what isn't in A, what isn't B, and then, it's easier if you just write it out and then just look for the ones that match, right? It's substantially easier. So if I go not A and B, B has 5, not A has 5. Cool. B has 10, not A has 10. Cool. B has 15, not A doesn't have it. We're done. So it's just 5 and 10, right? So it is easier if you actually write out the complement set, because then you can just find the numbers that match. Instead of being like, okay, I have to find numbers that match that aren't in that, and now use my brain really hard. Okay. Go. So we'll go through these ones. These ones should have been easy. These ones should have been okay if you, let's see, I want to see how you do. Okay. So B and C. This is an and because I can write the word and with it. So what's in B and in C? What's in B and C? Nothing. So what's in here? The empty set. Now, this one is union, which means or, because if I try and write and, it looks stupid. And or often means more, so we might get more than if there's an and. So A or C. If it's in A or it's in C, I list it. So I get 3, 6 is in both, 9, 12, 15, 18. Okay? Then we have A. This symbol makes the word and, so it has to be in both if I list it. So what's in A and C? 6, 12, and 18. Actually, all of C is in A. So what could you tell me about C and A? C is what A? Yes. I saw some people whispering it.
It's a subset of
It's a subset of A. C is a subset of A because everything in C is actually in A. Right? So if all of one set is the intersection of the other set, it's a subset. Okay. This one looks a lot worse than it is. It deceptively looks bad. It is bad if you choose to be lazy and not do the work. Okay? So Symbol. Really fun religion activity. Probably very jealous. Yeah. Yeah. Kind of romance. Yeah.
Looking for things. Well, they get a list of things and they're supposed to look for things out of school. It's like
Yeah.
the chapel called, what's the same name of this room, what's this hallway called?
Yeah. So you scavenger hunt and find the thing.
Yeah, exactly.
Okay. So, remember with anything with bed mass, you always start with brackets, correct?
Yeah.
Same thing here. So we have to do the brackets first. So we are going to do B or D first. B union D first. Bud. Okay? We're going to do that one first, and we're going to write it out. So, B or D. So what's in B or in D? A lot of things, correct? All of D and all of B is in B or D. So let's write them out. So we have 2 is in D. And then 3 is in D. Nope, that's a lie. 4 is in D. And then 2, 4, 5 is in B. 6, 8, 10 is in both. 12, 14, 15, 16, and 18. Right? Do we agree? So that's this one. Cool. Let's pretend that this is just not 2 letters. Let's pretend that this we could call this like Z if we really wanted to, correct? And we could say, hey, B and D and Z, or this Z equals B or D. We could technically do that if it made our heads better understanding of it. So we now want what's in A and Z. So we want what's in A and all of these, correct? So we're trying to find A and symbol, our new Z, which happens to be B or D. So in the set A, I have 3, 6, 9, 12, 15, 18. In the set Z, or B or D, is 2, 4, 5, 6, 8, 10, 12, 11, 15, 16, 11. I think I wrote this as a 14, but it didn't write it. All right, 14, 15, 16, 18. Okay. So sometimes my marker doesn't actually draw when I draw. It's really awesome. So I want what's in both. So in A, I have 3. In B or D, I do not. In A, I have 6. In B or D, I do. Cool. In A, I have 9. In B or D, I do not. In A, I have 12. In B or D, I do. In A, I have 15. In B or D, I have 15. In A, I have 18. And in B or D, I have 18. So we're just listing what's in both. Do you see what I'm saying? So you have to look at A up top. You have to look at this one that we made, this new one we made, and list the ones that are in both. Correct? All right. Now we have to have A and B. So I'm going to do it up here. A and B. Because I'm doing this set first. I'm going to label it set Y. So I'm going to pretend that this is Y for now. So Y is A and B. So what's in A and B? Well, that's going to be 15. We agree? So now I want what's in A and B, which is 15, or, this means or, D. So if it's in D, or it's in this new set, I list it. Correct? So I'm going to list all of D plus the number 15. Correct? Because of the or. So I'm going to get 2, 4, 6, 8, 10, 12, 14, 15, 16, 18. Then this one is a bit tricky. I have to list what's in not A and not B, so the intersection of both, and then what's not in all of those. So I actually have to do this first. So in order to do that first, I'm going to list not A and not B up here. So not A is already listed above. We already did that one, correct? But I'm going to list it again anyway. So it's going to be 1, 2, not 3, 4, 5, not 6, 7, 8, not 9, 10, 11, not 12, 13, 14, not 15, 16, 17, and 19. Because remember, it's the numbers 1 to 19 that are not in A. Now we're going to do not B. So it's numbers 1 to 19 that are not 5, 10, or 15, which is a lot of numbers. So let's list it. Everything but 5, 10, or 15. So 1, 2, 3, 4, 6, 7, 8, 9, not 10, 11, 12, 13, 14, not 15, 16, 17, 18, 19. Right? Now I technically want this first. So what's in not A and not B, correct? So I'm going to do that here. Not A and not B. So if it's in not A or and in not B, I'm going to list it. So there's quite a few numbers there that are in both, correct? So there's 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, and 19. Right? Listing the ones that are in both. So I would get 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, 19. So that's this. That's what's in not A and not B, the complement of A and the complement of B, correct? And then what's this little symbol? The complement of that. So everything in the universal set that is not here is what I want. So the universal set is the natural numbers less than 20, so from 1 to 19. So whatever appears in here from 1 to 19, or doesn't appear in here from 1 to 19, I'm going to list for this answer. So 1 and 2 are in it, so 3. 4 is in it, so 5, 6. 7 and 8 are in it, so 9, 10. 11 is in it, so 12. 13, 14, 15. 16, 17, 18. So you're working in the same homework spot of the book, but we're just finishing these ones up. Now what does this mean 9A odd? You're going to see odd, it has like little Roman numerals. Like A has like 1, and then 2, and then 3. You're doing the odd ones. So you start at the first one and do the third one, then do the fifth one. If you start at the second one, then do the next one. I don't really care. Just don't do all of them. Do every second one. Okay? Same thing for B.